Hello everyone, my name is Dr. Tuba Koktay.
And I'm Dr. Ian Shelton.
Welcome to Astronomy Nights Online. Tonight's episode, we will celebrate David Dunlap Observatory's 85th birthday.
But before we go there, we're going to cover just a little bit of its history so you can get a better idea of what the observatory is all about. Okay. So the way we're going to do this is I'm going to break this up into decades, which seems a nice, convenient way to break up the history of the observatory. And we'll start back in the 1900s, so 100 years in the past. And so that's when Dr. Chant came back to Canada, but also to Toronto to start teaching at the University of Toronto as a PhD astronomer and, well, as a physicist back then. But within a few years, he convinced the University of Toronto to start teaching astronomy formally. And in 1905, we had effectively a sub-department at the University of Toronto. And at that point, he also had a dream of having a major telescope in Toronto. And so it wasn't easy to get, 20 years of hard work. And one of the people along the way that he befriended was David Dunlap. David Dunlap is a wealthy businessman back at that time. And in 1921, it was great. But unfortunately, David Dunlap passed away in 1924.
Then Dr. Chant approached his widow, Jessie Dunlap. Jessie loved the idea of erecting an observatory in the honor of her late husband, David Dunlap. So she fully funded the project.
Right. And so construction started by lots of ideas, but basically blueprints and everything else was drawn up, and the construction was actually done completely in England. And so this is, the picture on the left-hand side is the telescope being erected and tested in England, and on the right-hand side, we're seeing the parts coming back to Canada and being assembled here in Canada. So that's busy 1930s. And then here we've got the big day, the dedication ceremony on May 31st in 1935. Lots of dignitaries came for the occasion. We've got on the right-hand side, you might recognize him as Lyon Mackenzie King, in between his 2 terms as Prime Minister in Canada. And on the left-hand side of the picture, we can see after the dignitaries have their chance, the general public was invited to look at the telescope, this wonderful 74-inch telescope, the second largest telescope in the whole world at that time. And then, of course, this is in the daytime, but now we carry on with that same tradition 85 years later. Not only do we let you see the telescope, but we also let you look through the telescope on clear nights during the summer.
Here you can see the observatory in the big farmland in the late 1930s. You can see many buildings and houses around it back then.
Yeah, so ideal for doing astronomy, at least back then. So 1930s were not just the dedication ceremony, but now you actually have to do something to the observatory, and that needs staff. And so Dr. Chant actually retired on the day that the telescope was dedicated, May 31st, and his second in command became the director of the observatory. So that's on the right-hand side of the picture over here. And so that is Dr. R.K. Young. And so he stayed on for almost 20 years as director. And then 2 other colleagues that came from the Dominion Astrophysical Observatory in Victoria came to support him. So we've got Helen Hogg and her husband Frank Hogg came from the observatory in Victoria as well. And of course, Helen's gone on to be the darling in lots of people's minds about astronomy in Canada.
1940s are the difficult times with many people volunteering for the war, but the operations still continued. Here in the picture, you can see Dr. Helen Hogg on the Newtonian platform gathering observations for the objects most she loved, the globular star clusters.
Yeah, beautiful. So after the 40s and the hardships of the war, things started to pick up very, very quickly. Here we see in the picture Dr. Don McCrae, who initially started out as a replacement as a theoretician for another astronomer that was there in the 40s, Dr. Williamson. But Dr. McCrae went on, of course, to be another director at the observatory and had lots of great ideas, including things like radio astronomy. The 1960s were sort of a transition year. So what happened is that the McLennan physics labs were completed in 1967, and then the staff were invited to move out of the old physics building at the University of Toronto to move into the new physics building. And in the process, a lot more students were enrolling into astronomy formally, and so the staff at the observatory, about half of them decided to start teaching downtown. And so the observatory continued, and things all continued as usual. It was the head of the astronomy department until 1978, effectively, when things like faculty meetings and colloquia finally moved completely downtown. And the beautiful library that we can still, even to this day, at the observatory, continued operating as the main observatory, as the main library at the Department of Astronomy until 1983.
1970s is a spectacular times for the DDO, with Dr. Tom Bolton's biggest discovery of the first non-black hole, Cygnus X1.
So you can see this beautiful recreation, but again, he was studying the star that became, the evidence that he needed to prove that the thing that was orbiting was in fact a black hole.
Here in the picture, can you spot us actually? And there is our guest speaker, our guest presenter is in the picture too. If you look carefully, maybe you might be able to spot him.
So 1980s, 1990s were very, very busy times. Basically the pinnacle of operations at the observatory. This is during the Christmas countdown. Lots of people showing up for this party, but it just shows you how many people were involved at the observatory. Students, graduate students, postdocs, as well as faculty and staff. And of course, that brings us 100 years forward into the new millennium, into year 2000 and beyond. That's also transition years where the University of Toronto basically ends operations at the observatory, and now it's taken over by the city of Richmond Hill. Okay, well, thank you very, very much. So hopefully that will give you some idea of what's happening at the observatory over the last 100 years, or how it got to be the observatory. And we've got a special treat for you. We've got a colleague who you might have, like Tuba pointed out, was actually in that previous picture. See if you can spot him in the doorway, Dr. Stefan Mochnacki. So we'll move on to that in just a few seconds. Welcome, everyone. All right, we have a guest tonight. We have from the University of Toronto, Associate Professor Emeritus Stefan Mochnacki. He will talk to us a little bit about what it was like to be at the observatory a few years ago when we were doing science research with the observatory. So Stefan, quick question for you just to start. So when did you first come to the observatory, to the DDO?
Well, I came in 1981, and at that time, the center of the department was still at the observatory. The main office and the main library was still here. It was still at the observatory, as well as, of course, the workshops. And it was a very lively place at the time. Within 2 or 3 years, though, that had sort of changed, and the center of gravity definitely moved downtown. Just those of us that kept our main offices at the observatory, people like Tom Bolton and Bob Garrison, myself and Don Fernie, stayed at the observatory for 2 or 3 days a week, and the other days we would be teaching in downtown and taking part in meetings. But in my case, I spent a lot of time at the observatory because I was involved in building equipment. We had very good technical staff at the time, very high level. And when I came, Peter Martin had just built an instrument for the Canada-France Hawaii telescope, a polarimeter, which had been shipped out. And I got a pretty big grant to build a photon-counting spectrometer. We called it a SHECTOGRAPH for the 74-inch, because at that point, the data was recorded photographically. We used photographic plates, as had been done ever since the telescope had been opened in 1955. So I set about making an electronic detector. There had been an earlier one by Bruce Campbell, who'd done a PhD there in the 1970s. But this instrument was now essentially obsolete. We wanted to get a modern instrument, so we built this photon-counting spectrometer. And that kept me pretty busy for several years at the observatory. I hired some students to help out, and our technical staff did a superb job. We basically improved on Shelton's design. We improved even on the CFA design with very good help from Harvard Smithsonian and Dave Latham and his group. And so we built this instrument, and by the late 1980s, we were doing digital observations, which we still have. And then by the late 1980s, there was a revolution in technology, and we went on to an exotech called CCD, which is much more like the kind of camera people use now, in your cell phones and digital cameras. We use these charge-coupled devices, the CMOS devices, digital detectors that are much more like what we use, except ours was scientific. It was cooled with liquid nitrogen, and it was able to observe stars that were quite faint. And so that was how I began. I essentially started out as more as an instrument builder than anything else. And then after that, I did a lot of observing of double stars, binary stars. And here we're doing spectroscopy. So we're basically dividing up the light of stars into their rainbow colors. But we do this very precisely and very high resolution, in such a way that it can see the signatures of all the elements and compounds that are in the atmospheres of these stars. And we do it sufficiently accurately that we can actually see the motions of stars. And just like when you hear a train coming towards you, its whistle will be much higher than when it's moving away from you. We call it the Doppler effect. The wavelengths are shorter when it's coming towards you and longer when it's going away. And we have the same thing with light. So we're actually able to actually measure the movements of stars using spectrograph. And this is exactly what we were able to do best with DDO, was to measure the movements of stars accurate to about half a kilometer a second or 1 kilometer a second. And particularly this allowed us to do things like measure the masses of stars and the sizes, and by doing simultaneous spectrometry, Don Fernie, who had been the director there in the 1980s, had built 2 photometers, one on each telescope, small telescope. We had 2 smaller telescopes on the roof of the main building. And I had a student who for several years observed stars with these photometers at the same time that he was observing them with the spectrograph on the 74 inch. With these simultaneous observations, we're actually able to see star spots on close binary stars and see how these star spots actually moved around these stars. It was very difficult work, of course, numerically, because the computers had to extract this information from the observations. It's quite a massive piece of work. But that was the kind of thing that I was involved with in the 80s and 90s in particular at the observatory, using the detectors that we had built.
So that was, sorry, so that was with Paul Hendry, the tomography?
Yes, that was Paul Hendry, yes.
Yeah.
We published nice papers out of that. But it was really difficult work, and a number of other people have tried that kind of work, but nobody's really persisted with it for terribly long, because it really is very difficult.
Yeah, it's difficult.
Yes.
Yeah.
But it did tell some interesting things.
So you've been there for a lot of the Renaissance, when the observatory went into digital mode and started to do photon counting, which is, so that's the legacy of the observatories. It's been progressive. It always keeps upgrading itself to stay current, which is kind of nice.
That's right. That's right. And that worked very well. But after a while, people, of course, Canada put a lot of money into building the Canada-France Hawaii telescope, and then other telescopes that we went into partnerships with other countries. And these were built, of course, in superb sites that would get 80 and 90% clear weather, like yourself, you know very well, after the years you spent down at Las Campanas. And that's another example of and so, of course, in a place like Toronto, we're lucky to get 30% or 40% clear weather. And even then, it's not particularly good, or at least it was not particularly good. And it's really only suitable to do spectroscopy. And because of the bright sky, because of the lights from the city, the only thing you can really do is spectroscopy with relatively bright stars at fairly high resolution, where the sky doesn't really trouble you as much. But unfortunately, science has moved on, and people now want to observe galaxies at the edge of the universe and all kinds of weird and wonderful objects that are many, many times fainter than what we could observe at Richmond Hill. So the number of people who are observing Richmond Hill just dropped down, and all the new faculty we hire, we're doing all their observations either in space or at these very advanced observatories in places like Hawaii or Chile. And the people that were doing the stellar observations were, of course, getting older and retiring. We had fewer students doing that kind of work. And of course, this meant we didn't get much more money to upgrade the equipment. We could have, for $500,000, we could have very well gotten into the game of finding planets around other stars, but just that sort of money just wasn't available. Simply because people thought the weather just wasn't good enough in a place like Toronto to really make it worthwhile. So it sort of, and then finally we got another CCD when the original one died. And then it just, what we did do, however, in the last 10 years, I think a very valuable piece of work was done. And this was led mainly by Sławek Retiński. I was involved with it. And quite a few Polish astronomers were involved with this as well. And this was observing very close binary stars called contact binaries spectroscopically and getting really good data on them. And then Sławek developed a technique that you could measure their masses, or at least the ratio of their masses, very accurately. And this, we got about 100, 120 of these stars very well observed. And this provided a really important database in the last few years. Another thing I did, I found students could use the telescope very well. And around the year 2000, I had a class, a dozen or so students, and we observed about 60 very cool little red stars, and published a very nice paper out of this. There was also a group of graduate students that were observing the effects of clouds falling in on the galaxy, and that also yielded some very nice papers.
That was an excellent
survey.
So,
yeah, I guess you both guys, you remember.
Yeah.
Yeah, and so that I think was a very fruitful little period there. But unfortunately, the equipment, there just wasn't the investment being made anymore. And in fact, people that really wanted to do that kind of observe stars became fewer and fewer. And so eventually in 2008, the property was sold and the observatory was closed, while I had been conveniently sent away on sabbatical in Austria, because I suspect I was offered this earlier sabbatical, so I wouldn't be here when it happened, because perhaps I was one of the few people that might be able to cause a bit of a stir. But I didn't. I felt, unfortunately, this was the only way at that point that we could really go, and it was really sort of sad, but things had moved on.
Yeah. In the end, the observatory itself is still functional. It still has the same light gathering power. Richmond Hill has gotten a little bit brighter, but from our records, it's been holding its own. Going to LED lighting maybe is something that might be a battle for the future. But in the end, the telescope still has value because there's still many thousands of interesting brighter objects in the sky that are getting neglected and need to be attended to. So I'm
exactly.
still hopeful. Yeah. So it still has a social purpose.
High dispersion spectroscopy can certainly be done. And also, interestingly enough, we observed that the seeing got better there. The quality of the images got better for two reasons. We cut back the trees a bit around the observatory, but more importantly, it looks like there is a sort of a thermal dome over Toronto. And as Toronto has grown at this enormously rapid rate in the last 40 years, the seeing seems to definitely improve. So the kind of devices we had back 40 years ago, we called them image slicers, to concentrate the light into a smaller image at the focus of the telescope, were no longer really necessary, were no longer used by the time the observatory closed. The seeing had gotten better, and our instruments were better too.
Yeah, I do confer, and I guess this October we'll try it on Mars to see just how much better it really is, but for its opposition. So we are seeing that the imaging on good nights can actually be quite surprisingly good. So we're guardedly optimistic that it'll have a second lifetime, second future to it. So at least for citizen science, if not hard science.
Yes, well, I'm certainly very glad to see that this work, that something useful is now being done again with the telescope. I very much hope, of course, that the institutional memory, people like Archie Ritter, who's been maintaining the telescope, will be preserved. because one of the really critical is that the telescope be maintained and illuminized. And we're talking here about technology that's 80, 90 years old, and this needs to be well recorded, and because there are many things that are done that don't make much sense, but are in fact necessary. So I very much hope that this institutional memory is preserved, and that will allow the observatory to continue as an observatory. Absolutely,
absolutely. That's one of our mandates, was to try to preserve the not just the history per se, but the ongoing history, to keep the observatory maintained. It's a unique device, and even though it's the flagship for 6 other units like this, it's still unique because they don't build telescopes like this anymore, which is actually not a bad thing. It's actually incredibly well built. So it's just a matter of maintaining it, and knowing how to maintain it is different. But we're also trying to upgrade it. So all the time, just make it improvements. Yes. Don't undermine it, but keep it healthy and even more productive than it was in the past. Yes. So
that's right. I mean, it really does actually produce a pretty good image. It's a good telescope, and the size of it is quite unusual, and it really can be very interesting. And it can actually be pointed very well, and it'll track stars well.
As well.
It is in fact a good instrument. It may not be the sort of thing we find on the peaks of Hawaii or Chile, but there are certain things which on these giant telescopes you just cannot do. You cannot get the time to do many of these little projects or so on. But a telescope like the one of DDO can do that, and I think that is very important to maintain that.
So, Stefan, how was your typical day at the DDO? I remember when I first came in the 90s, we met. You were running in and out of the DDO completely, and you were helping with the observing too when I was just a student there.
Well, yes, I was actually observing. I was observing there.
Yes.
Quite a bit. We built these instruments and got them going. In fact, I think which month was it that you discovered your supernova, Ian? Was that February or January? I forget now.
It was February.
Yes, February was also the month I spent almost the entire month observing February. It was also the coldest month I think I ever experienced in Toronto.
Wow.
It's fine for me.
Just about observing. And that was when I had my instrument going, the photon counter going for the first time. And it was a very interesting time indeed. And I think there's a photograph I sent you, which I think it was from that time. 2 photographs. And so we were, this is from 1987 to 1990 or so, the SHECTOGRAPH was used quite a lot. And so I did, but that was about the only time I was really observing continuously for weeks on end. And of course I had to go downtown and teach as well. So it was, I was a lot younger than now, and I was able to do it, but still it was but usually I'd only observe, we'd only observe say 4 nights a month or something like that, or 4 or 5 nights a month. The rest of the time we'll be doing my work in the office, doing research work, working on a computer, writing papers and that kind of thing. And that was so the same kind of research. It was very nice because of course you didn't have people disturbing you, i.e. students, but of course downtown, and we made up for it when we taught for 2 or 3 days, had to be downtown a week. And
there were a few students there. We did have a few students there. So.
Oh yes, we had a lot of students. In fact, what was wonderful, especially in the summers, that was wonderful. And especially in the late 80s, early 90s, mid 90s, when we used to play volleyball every noon. This was a tradition at the observatory. When I first came here, it was very active. Carried on for a long time. And that volleyball was certainly wonderful. I remember sometimes we'd have 20 people out there playing. It was everybody just about playing, except the office staff perhaps.
Well, that was the great equalizer. There, from the machinists taking on the lofty faculty. Yeah, it was definitely nice. And it was a ritual, no matter what. Even if it was raining, the poles went up in the parking lot, and yeah. So for the most part, it took a lot to discourage us.
40 minutes every day. I think it was 20 past 1 o'clock. We had lunch. 20 past 1. We'd go out there. We'd play 40 minutes of volleyball. Then we'd come back and up to the club.
Yeah. I remember when Bob took me first time there and then introduced me. Let's go volleyball. We have to do that. It's a ritual. And then I met you that day too. I remember.
Right.
Yeah.
Well,
So
that's,
Yeah.
and of course the picnics.
Yeah, the picnics were
right, I was going to say that. The annual picnics were wonderful.
Yeah,
Yeah.
And
those
the whole
probably,
department, everybody would come out,
Yeah.
and it was really wonderful, a wonderful event every year. And then, of course, we would have a party every October, so we'd have a party at the
Yes.
director's house
Yes.
for the entire astronomical community, which sort of grew as the seat of built up. So everybody in astronomy would come there, and of course, then just before Christmas, we had something called the Christmas countdown.
Yeah.
Countdown was actually that's what the seminar used to be called. But of course, this was a sort of a party, and we actually used to have acts and skits, and it was like a little concert, and then after that we'd have a party. It was in the daytime, it was in the afternoon. That's why, because it used to be what used to be the seminar time. Back up until the late 70s, of course, the seminars were actually even held at the observatory. So that was also a great tradition, but unfortunately, it sort of died away again in the 2000s as the downtown people came in. The people had never even been to the observatory took over, and people thought it was too far to come up there to Richmond Hill, the 25 kilometers. But the department used to have its own vehicles too. It used to have its own station wagon downtown for the grad students to go up, and also we used to have a vehicle at the observatory too for delivery, for getting stuff and so on. But that again was canned somewhere around the turn of the century, if not earlier. And because I certainly remember, so in the late 1990s, I was actually driving students myself in my own. I had a minivan, so I used to drive. I remember driving students to the observatory and back.
The observatory was always community. I mean, that you live local. A lot of the astronomers lived local in Richmond Hill, so it was just like walk to work. It was, and so when people came, it's the park setting and everything else. It was an oasis in the middle of all the hustle of urban living and teaching and studying. So it was.
We even had deer living in the observatory grounds.
Yeah,
and they got quite numerous towards the end. We had about a dozen of them there.
Yeah,
so it was quite an oasis indeed.
Yeah, even the wildlife discovered it as an oasis. So there's still the deer on the property, so they're quite comfortable.
Really?
So things have not changed that much in the end, which is reassuring. So
wow.
We're
last time I was there a year ago, and I remember driving past. A lot of the open areas have been built up now, I believe.
Yeah, the price to pay to preserve the central part of the observatory property. So so, but in the end, it's we're hoping that it won't undermine ongoing access to the nighttime sky. So that's so we have other issues, but the LED lighting is more directional. There are some advantages to it. The disadvantages are that it's broadband. But we're
yes, and concentrated in the blue. So,
yeah. So certainly for classical spectroscopy, it's a problem. It will be
for lower resolution. But if you have high resolution work, it's not so bad.
Yeah. No. Okay, so we've out of time, unfortunately. So it has been really, really nice to have you with us. We'll invite you again in the future for sure. We'll have more conversations. This has been really, really pleasant, really nice.
Sure.
So thank you.
Lots of things to talk about.
So can we say happy birthday video together?
Yes.
I'm not sure about that.
Nice to see you.
Gonna sing?
Yes.
Well, let's just say thank you very happy birthday.
Happy birthday, video, 85th birthday. They're having a special guest, Stefan. So thank you, Stefan.
Oh, really? Oh, wonderful. Great. That's great. Indeed. You're right. 21st of May.
Yep. Yeah.
Yes.
31st of May, yes, 85th, yes.
That's right. I remember that. I will never forget the 50th. That was rather too eventful. Let's put it that way.
Yeah.
You guys, this may have been before your time.
Just a bit.
For sure, before my time.
The 50th was a little bit too eventful. Remember, you know why? It was the great tornado that went through Barrie.
Yeah. Just for me, I was not in town, so.
That's right.
Yes. Yeah.
Okay.
Right.
So thank you again very much, Stefan, and we'll say goodnight. Well, for now, and we'll speak to you again in the very near future. Thank you very, very much.
Thank you very much. Thank you.
Thank you for joining us for the second episode of Astronomy Nights Online.
And to end off, we've got some slides from the 84th birthday last year when we could all be together.